All right, let's get right into it. We're going under the hood of Windows today to tackle something pretty fundamental. How exactly does it decide who gets to access what? Why do you sometimes get that super frustrating access denied pop-up? We're going to break it all down. Oh man, we have all been there, right? You click on a file, try to change a setting, and bam, access denied. It can feel so random, but I promise you, it's anything but. What just happened is that deep inside the operating system, a really complex security check took place. So the big question is, how does Windows actually know it shouldn't let you do that? So here's our game plan. We'll start with the basic question of access control. Then we'll look at your identity in the system. That's SIDs and tokens. From there, we'll cover the rules, which are called security descriptors, then see how the final decision gets made by the SRM. And finally, we'll tie it all together and see why this stuff really matters. First up, the access control question. And yeah, it's way more than just your login. Think about it. Every single time you do anything on your computer, you open a file, you launch an app, you're kicking off a series of security checks. The operating system is constantly asking itself, okay, does this person using this program have permission to do this thing to that object? And it has to get the answer right, instantly, thousands of times a minute. Okay, so for Windows to answer that big question, it first has to know one crucial thing. Who are you? And I don't just mean your username. We're talking about a rock-solid, verifiable digital identity. This is basically the foundation of the whole security model. And at the heart of that identity is something called a security identifier, or SID. The best way to think of a SID is like a unique serial number for, well, everything. Every user, every group, even the computer itself gets one. It never changes. It's the one true way the OS knows that you are you and that the administrators group is the administrators group. Your username? That's just a friendly nickname slapped on top of this much more important number. Now, here's where it gets cool. When you log in, Windows doesn't just hand your one little SID around. Instead, it builds you an access token. I love this analogy. Think of it as a digital wallet. This wallet gets attached to every single program you open during your session. Inside, it's got your personal SID, of course, but it also has the SIDs for every single group you're a member of. So if you're an administrator, that SID is in there too. It's your complete security profile for that login session. And this wallet isn't just for ID cards. It also holds what are called privileges. These are really important. They aren't about accessing a specific file. They're more like system-wide superpowers. For example, the privilege to shut down the computer or to take ownership of a file that isn't yours. So your access token doesn't just say who you are. It also says what powerful things you're allowed to do across the whole system. All right, so we've got your identity sorted with the access token. Now, let's flip things around and look at the object you're trying to get to. How does a file or a folder have its own set of rules? Well, it has its own little rulebook. See, pretty much every object in Windows that can be secured, we're talking files, folders, registry keys, you name it, has this thing attached to it called a security descriptor. This is that rulebook. It holds all the security info for that object, who owns it, and most importantly, the permissions list of who can do what. And the real heart of that rulebook, the part we care about most, is called the Discretionary Access Control List, or DACL. You can just think of the DACL as the bouncer's guest list for the file. It's just a list of entries, and each entry says something like, this SID is allowed to read, or that SID is denied the right to write. That's it. It's a list of allows and denies tied to specific SIDs. Okay, so now we have our two main players on the field. On one side, you've got your access token, your wallet full of SIDs. On the other side, you've got the object security descriptor, its rulebook. So, who makes the call? We need a referee. And that referee is the Security Reference Monitor, or SRM. This thing is a major part of the Windows kernel running at the very core of the operating system. It's the ultimate judge. Every single access request has to go through the SRM. It's the one that has the final, non-negotiable say. It's the code that literally says yes or no. So how does the SRM actually do its job? It runs something called an access check. It's pretty logical, actually. It takes your access token with all your SIDs, and it walks down the object's DACL, its list of rules, one by one. Now, here's a super important detail. The first thing it's looking for is an explicit deny entry that matches any of your SIDs. If it finds one, bam, game over, access is denied, right then and there. If it gets through the whole list without finding a deny for you, then it starts adding up all the allow permissions that match your SIDs to figure out exactly what you're allowed to do. But just when you think you've got it all figured out, there's a twist. There is another, totally separate layer of security. Think about this. What if some malware is running under your account? The DACL would probably let it do bad things, right? Because it's running as you. To stop that, Windows has something called mandatory integrity control. This system works by assigning an integrity level to, well, everything. Every program and every file gets one. And this isn't about who you are, it's about how trustworthy the process is. For example, your web browser, which is browsing the wild internet, might run at a low integrity level. Most of your normal apps run at medium. When you do an admin task, that runs at high. And the core OS itself, that's at the system level, the highest of all. So this gives us 2 layers of defense, and it's key to understand the difference. The DACL, the first check, answers the question, who can access this? And it's set by the owner of the file. You set it. But mandatory integrity control answers a different question. Is this interaction trustworthy? And that is set by the operating system itself. The golden rule here is super simple. A process with a lower integrity level can never write to an object with a higher integrity level. End of story. That's what stops your low-integrity web browser from messing with your medium-integrity documents, even if the DACL says your user account can. Okay, so why does any of this techie stuff matter? Because this isn't just theory. You see this entire system in action on your desktop all the time. It's the engine running some of the most common Windows features you interact with. You know that user account control pop-up, the UAC prompt? What's really happening there? The system is literally asking you, hey, are you sure you want to give this program a powerful, high-integrity token? It's a big deal. And when your browser says it's in protected mode, now you know what that means. It's being forced to run at a low integrity level, effectively building a wall around it so a bad website can't get to your personal files. This whole 2-layer model is the foundation for sandboxing and so much of modern security. So the next time you get hit with that access denied message, you'll know it's not just some random error. It's this incredibly detailed 2-layer system at work. It's the SRM checking your token against the file's rules and checking the integrity levels. It's a whole security dance happening in a split second. So my question to you is, now that you know the rules of the game, does it change how you think about the apps you run and the security of your own stuff? Something to think about. Thanks for joining me.
If you want to help me out, please smash that like button, leave a random comment, and subscribe if you want to become a better hacker.